$500 leave your bank account, it never arrives and the system crashes. What exactly did cause this problem and where did it go? That is exactly the issue that database transactions exist to solve. A transaction is a group of database operations that are treated as a single unit of work. Either all of them succeed together or none of them do. There's nothing in between. Transactions will end in one of two ways: a commit, which means that changes are saved permanently, or a rollback, which means that everything is undone as if it never happened. Transactions are governed by four guaranteeing principles, which are acronymed ACID. Atomicity, that means that the transaction is all or nothing. If the transaction, for example, has a transfer that deducts from account A but crashes before crediting account B, then it's going to roll back. Both operations succeed or neither does. Consistency means that the database must move from one valid state to another. Every rule, constraint, and relationship must hold before and after the database state. No transaction can leave the data in a broken state. Isolation means that concurrent transactions must not interfere with each other. For instance, if two users book the last seat on a flight simultaneously, isolation will ensure that only one of those transactions succeeds. And databases achieve these through locks and isolation levels. For example, read uncommitted locks all the way up to serializable function, which we'll delve into in another video. Durability means that once a transaction commits, it stays committed. Even if the server crashes 1 second later, the data will manage to survive. This is achieved through write-ahead logs and persistent data storage. Without ACID, you get a bunch of potential problems. The first one is dirty reads, which means that you're reading data another transaction has not committed yet. The second problem is phantom reads, which means that a query is returning different rows depending upon where you run it in the database. And lost updates mean that two transactions try to overwrite each other's changes simultaneously. The ACID properties make these potential situations impossible or controllable. So to wrap it all up, atomic, consistent, isolated, and durable. Those are four properties and one promise that for a database, your data will always be trustworthy. If you enjoyed this video, be sure to like, comment, subscribe, and share your thoughts down below. I'll see you in the next one.